Do you think you can see that's aluminium, and we're adding a few drops of sodium hydroxide, and it gives me a white precipitate. What happens if I add an excess? Excess means adding more. It becomes really my performance or the computer's performance? Seriously. Okay, so immediately when you add double, it is gone. So it's as if you don't add ammonia, which precipitates it out again. It happens. Right. So what happens if we add the ammonia to aluminium? Andrea, what happens?
White precipitate.
Is there a white precipitate? Oh, there's a precipitate in there. You see, sometimes it is really faint. Why is this thing not focusing? Focusing. Oh, okay. Right. If I add more, what happens? If I added an excess? It's insoluble, so that precipitate stays. It's not going away. Done. Dust. Next one, ammonia. What happens to ammonia?
There's no precipitate.
There's no precipitate with sodium hydroxide. There's also no test with ammonia. But what it does tell you is that when heated, it gives off ammonia. So this is your ammonium ion that gives off ammonia. Ammonia gas, is it acidic or basic? Basic. So how would we test for ammonia gas? Red litmus turning blue. Okay, so we're going to do that now when we light up our Bunsen burner. Okay, so barium. What happens to barium if I add a bit of sodium hydroxide? Oh, a nice white precipitate. Okay, so there it is again. There's my white precipitate. What happens if I added an excess?
What's the same?
The second line.
Observed unless reagents are pure. It says faint white precipitate is nearly always observed unless the reagents are pure.
Right, so there's my white precipitate, and it stays. So with barium, even so, it's there, right? It's not going to dissolve. So that's my sodium hydroxide. What about ammonia? What happens in ammonia? Also, precipitate doesn't dissolve. So immediately when I add it, there's a white precipitate. What happens if I add excess?
It just has no precipitate.
No precipitate. Yeah.
Yeah. No.
There is something there. Look at it. There's something there. Is the test lying?
It's like soluble, but it's like not. It's like clear. It's not. What is it today?
No precipitate.
But look at my barium in itself. There's something horrible in there.
Well, that's the one I really estimated.
Okay.
So maybe I've done it really wrong.
Right, so we need to retest for this. Look at that. There is actually something in there that looks exactly like this, isn't it? So something, there might be a contaminant in there. So we need to redo the barium one. Okay, that's okay. We can do that. What about calcium? What does calcium say with sodium hydroxide? White precipitate. So do you see my... Oh, this is a nice white precipitate. Look at it. It's very nice and white. Right, so what happens if I add excess? Nothing, it just becomes more. And it's still a white precipitate, so it stays insoluble. What about my ammonia? No precipitate. So adding, nothing, still nothing, adding more to double the volume, nothing, right? So This is a nice clear test for calcium. So with sodium hydroxide, white precipitate. With my ammonia, no precipitate. And this is the thing about the complex, right? So if we have the hydroxide ions around it, it makes white, get the white color. If you have ammonia ions in the complex, it gives a colored solution. Very nice. All right, chromium. Now, what does it say for chromium? What happens with my sodium hydroxide?
Gray, green, precipitate.
Look at that. There is a gray-greenish precipitate in there. Okay? And what happens if I add to excess?
It's soluble.
It's soluble. So it means that precipitate at the bottom should disappear. Okay, so let's try this. There's also something in my sodium hydroxide that says, ooh, it becomes just a green liquid. So there's no precipitate, which means the precipitate was soluble. But there's still a color, and it's a very nice green color. And this is the type of observation that you need to do. So Andrea, with giving your observations, it is important to know, is this a liquid or is there precipitate? Precipitate would be if you do this or let it stand for a moment in time, there would be things dropping down and lying on the side. Or there would be white granules. Look at this. This is a precipitate. To the side, you can see there's some granules. That's a precipitate. So, right, let's look at ammonia and my chromium. What happens?
It's also green, gray, precipitate.
Oh, but do you see there's a slight difference? No, there's no difference. It looks exactly the same. What happens if I add an excess?
It would be insoluble.
Also insoluble. Oh, insoluble. Sorry, that was missed. So you can see definitely that color remains, the precipitate remains, while the other one is in liquid. Nice. I like it when things work. Barium, you bugger. Right, okay, let's look at copper. Now, copper is the nicest color. I told you yesterday, Andrea, copper is my favorite iron. So here we've got blue. Adding my sodium hydroxide, what happens? I get a nice blue precipitate. Look at that nice blue precipitate. You can see the granules through the side. All right? Blue precipitate. What happens if I add this to excess?
It's insoluble.
It stays insoluble then. Okay, there we go. So insoluble, that gunk is still sitting in there. It's actually yeah. That's with copper sulfate crystals. That's with copper sulfate. Okay, copper ions, ammonia. Oh, look at that deep blue. Again, and if I add more, it becomes just a blue liquid. So it's first a deep blue precipitate, and then as I add more to excess, it becomes a blue solution. So it's soluble and it gives me a blue solution. So that's really important in your description. The favoriteest one to ask is the iron 2 and iron 3. Let's see. Iron 2 with your sodium hydroxide, what happens?
It's green, precipitate.
Ooh, look at that. That's cool. All right, what happens if I add it to excess?
Insoluble.
Insoluble, so it stays that way. Okay, so there's my green precipitate in the bit of yellowish liquid. Okay, fine. I'm going to leave it there. What about Fe2 plus ammonia? Oh, same thing. And what happens if I add more? Also insoluble. But have a look at what is happening to my test tube. Why?
It's reacting with oxygen.
So what do we call that?
Oxidation.
Yes! You're brilliant! And you'll see this happens really fast. This one is slightly slower, but it's also going to turn brown. So very, very nice. So look at the rust. That's literally a rust that it's dragging down. So what happens to iron 2? Because iron 2 is the most common one that we have, it rusts. So what about iron 3?
It's red-brown, the same shade.
So it's already red-brown, so it's not going to oxidize further. So this is how we distinguish between iron 2 and iron 3. Your iron 2 is going to oxidize. Iron 3, also a red-brown precipitate. Is there something that happens if I add it to excess? It just stays my red-brown precipitate. Very nice. So it's already in its oxidated state of +3. So this is what can happen to iron. Iron +2, iron +3. Oh, just look at that. One can become poetic about this, isn't it? It's just lyrics in Afrikaans. Right, okay. So manganese. We're back to our group 2, so we expect a white precipitate, isn't it? Yeah. Oh, but what's happening?
It says rapidly turning brown in contact with air.
Yes, look at it. At the top there, it's turning brown. So a white precipitate forms and then it turns brown. That's just very cool. Is there something that happens if I add it to excess? So let's try that, because this is what you should do always to confirm the test. Always a few drops and then an excess. If there's no change, then you write no change. You actually get a mark for saying no change, if there's really no change. What about Fe2 with ammonia? What happens? Same thing. Oh, immediately. But it's even quicker turning brown, isn't it? So that's that brown. Right, so same thing. Let's do manganese. What do we expect?
I thought we're in zinc now.
Sorry, I did manganese now. So manganese gives me also a white, but there's also a browning. Is there supposed to be a browning?
Just mention.
Don't mention it. What happens if I add it to excess? My sodium hydroxide.
Soluble.
I'm going to see if you are right.
I think we're just doing manganese twice. You're only about.
No, this manganese. The other one was magnesium.
It's still the same thing. Although magnesium doesn't mention about turning brown, manganese does turn.
Oh, magnesium did turn brown.
Yeah.
That's interesting. Okay, but manganese is not soluble in excess.
Yeah.
It's not. Right, and what about ammonia? Let's see what happens in there. Same thing, white precipitate that rapidly turns brown on top. What about excess ammonia?
Also insoluble.
Also insoluble. So what's the thing about magnesium?
I don't know. It says white precipitate insoluble in excess, which is technically true, but it's brown.
But it also turned brown. That's weird. Could have messed it up. Okay, what about zinc?
White precipitate.
Oh, do you see there's quite a few white precipitate? What's the difference? Is the white precipitate, is it soluble or insoluble in excess?
Soluble.
With sodium hydroxide, does it become soluble? Let's see. So I'm adding quite a bit to it. Yes, it's becoming soluble. It's not very soluble. Okay, no it is. Sorry, there we go. It's totally soluble. Usually you'll have a bit of a rubber stopper to do that. Don't use your finger. These are 2 molar concentrations, so it will burn you. It will burn you. It's fine. Right, what about zinc?
Same.
So white precipitate, as I add more, it becomes soluble. Okay, so that's fine. And those are my cations. There's just 2 questions, was the barium and the magnesium. So we'll just have a look at that.